You should also note that the use of the MCB reserves the use of some pins. That is to assure optimum performance for your system. To determine which pins are reserved for this purpose, refer to the Spartan-6 FPGA Memory Controller Block User Guide. But don't worry too much if you don't use the MCB. The I/O pins will default in that case to being used for general purpose, so you don't end up wasting any pins. You should also note that the package selection determines your access to the MCBs. This is also outlined in the MCB User Guide, but higher pin count packages have more memory controller blocks bonded out. This is important to remember. Migration across densities within the same package is supported, but with limitations. You should be able to migrate up or down one device density in most cases, but this only applies within a device family. You should also remember that the lower left memory controller block on the die is the easiest memory controller block to migrate to different devices because its pins are shared less with other functions compared to memory controller blocks on the right side of the die. The memory controller block can also be used to build larger memory controllers. They can be connected in parallel to create a wider interface if needed. However, this will require extra CLB logic and probably degrade the performance some. The MCB can interface to a single memory component in by 4, by 8, or by 16 mode, but there is no support for two memory controllers in by 8 mode to interface to a by 16 memory component. If you're planning on using the LPDDR memory controller, be sure to use an external VREF supply in the appropriate banks. This will support the soft calibration module input termination tuning functionality. Also, if you are floor planning your design using the MCB, be sure to use the PLL nearest the center of the device to drive the buff PLL MCB primitive. As I mentioned, the IC tools support the use of the memory controller block with the MIG within the core generator. This is best for all applications except embedded applications. Embedded applications should use the EDK tools, which give you access to the MCB when you use the multi-port memory controller, that is the MPMC. In this case, when you build this component, the memory controller block will be instantiated automatically if possible. The MIG makes it simple to add the MCB to your design. It allows you to customize the memory, data rate, bus width, memory component parameters, I/O bank assignments, and generates the necessary RTL source code for instantiation. It is important for you to remember that the MCB does reserve some pins, so you should use those that it assigns if at all possible so you can get the best performance. You will note that the MIG also performs all the necessary error checking to make sure that you are designing appropriately for the MCB. The MIG will store your pin constraints in your design's UCF file. In case you're not familiar with this file, the UCF is the designer's user constraints file. All design pin assignments and pin attributes are going to be placed by you in a single design file. It is then used by the implementation tools when building your design. And don't forget that if you need another type of memory controller not supported by the memory controller block, you can still generate other types of soft memory controllers when you use the MIG. There are a few other memory types that are supported by the MIG. The standard FPGA design flow still applies when you use the MIG. You will first customize your memory with the MIG. This will require you to set any necessary parameters and generate your controller's RTL and UCF files. You'll then need to perform a behavioral simulation of your controller and verify that it meets your needs. Then integrate the core with your design, synthesize your project, and implement your project. Note that timing simulation is still supported and encouraged, but is not required. Lastly, verify your design in hardware, probably by using one of our many demonstration boards. This slide just shows you a couple of screenshots from the MIG. In the end, you will have 6 or 7 GUIs that you'll have to customize your memory's parameters, customize the I/O banking for your controller, and set various options. The controller also has some debug and IOB options that will affect your controller's speed and power consumption on the physical layers, and these can all be set with the MIG. One of the more elegant features of the MIG is to gray out restricted columns for your device. This assures that you make a suitable controller for your density of device. As I mentioned, the MIG will make a UCF for your pinout and clocking constraints. It will also make the necessary RTL files, which are unencrypted and can be edited by the user. There is also an HDL simulation folder that is necessary for behavioral simulation support. In summary, Spartan-6 has a number of different memory resources. It has distributed LUT RAM, which is your lookup tables reconfigured to emulate a small memory. Great for localized memories, small FIFOs, ping pong buffers. I think we covered a number of different applications. But the big kahuna is the block RAM. The block RAM resources, again, are dedicated in the silicon, so if you don't use them, you waste them. So it's very important for you to try to manage that you use as many of the block RAMs as possible so you can get the most out of your FPGA. Now again, these are larger memories. We said 18 kilobit size memory, so it's a lot bigger than distributed memory. We also talked about the memory controller block, which is like block RAM dedicated. The MCB provides a fast connection to popular standard memory components. So anytime you're planning on using an off-chip memory, you probably want to evaluate that you can use the MCB. Now currently it supports 4 different memory controller standards. And again, it's ideal for large memories. Now, when using the MCB, okay, you're going to be building that with the MIG, and if you're planning on adding block RAM or distributed RAM, you're going to be using the core generator to build those memory components. Well, there is lots of useful information about memories and memory controllers that can be found on Xilinx's website. The Spartan-6 user guide provides very helpful and detailed information about distributed memory and block memory resources included in the silicon. All Spartan-6 users will probably want to refer to this document for the most silicon information. The Spartan-6 FPGA memory controller user guide is also very helpful when targeting the memory controller block. It includes a description of all the supported controllers, supported vendor devices, the necessary parameters you'll have to assign, etc. And it walks you through the various settings that you can be made and make with the MIG and describes all the necessary planning you should do when targeting the MCB. This includes pin planning and supported memory configurations. If you would like to see what other courses we offer or what other free RELs are available, go to the Xilinx education link you see here. I would also like to mention again that there are other architecture modules available that discuss the basics of Xilinx's newest devices. You may find these useful, especially if you want to learn more about the differences between the available FPGAs. Again, my name is Frank Nelson. You've been listening to the basic FPGA architecture module for Spartan-6 that describes the available memory resources, including the new memory controller block. Thanks for listening, and again, thanks for your attention and your business.